All right, so in this video today, I'm going to show you why we care about the unit circle. And you know, even at the end of this video, you still might not care, but that's okay. But the unit circle, if you remember, when we first started creating it, if I were to draw a grid, okay, with the X and Y axis on it, okay, get some tick marks on here for points and stuff, okay, the unit circle sits right here. That's where the unit circle sits. 1 unit in each direction. So this point right here, which is 1 on the X, 0 on the Y, corresponds to this point right here. That's why we gave it 1, 0, right? This one right here, 0, 1, corresponds to that point. This one corresponds to that one. And this one corresponds to this one right here, right? And so right here in the middle, this is 0, 0, right there in the middle, right? Okay. So just wanted to bring that up so we kind of remember what we're dealing with here. So what I want to do now is I want to take a look at this first angle over here. This is a 30-degree angle. So I'm looking at this one right here, this 30-degree angle right here. I want to draw the little triangle that we used to help us figure out how big this triangle was, or how big this angle was. So I have that distance right there. If you remember, this is our x value. That is square root of 3 over 2. And then we have the vertical distance to get to that point, so right there, which is 1/2, right? And I'm just going to finish it up with drawing in the hypotenuse so we can see the triangle. Okay, cool. So there's that triangle right there. Now watch this. If you remember our trig equations, we've got, let's do one over here. So sine, I plug in an angle measurement and it spits out a ratio between two of the sides. I've got cosine, same thing, and I've got tangent. So if you recall with sine, I plug in an angle measurement, okay, and it spits out opposite over hypotenuse. Cosine, I plug in an angle measurement and it spits out the adjacent divided by the hypotenuse. And tangent spits out opposite over adjacent. Okay, so remember those. So let's try that with this triangle over here. So what is the sine of 30 degrees? That's what I want to figure out, okay? So it's going to spit out two sides. So the sine of 30 degrees, opposite is on top, so opposite. This is the opposite side of the 30 degree. This is 1/2. Now, what is the hypotenuse? What is this length right here? Well, this distance right here represents the radius of this circle. In fact, it doesn't matter which of these lines I look at. It's always going to be the radius, and they're always going to be the same length. So well, let's look at this one right here. How big is this line right here? Remember, it's on this unit, it's on the grid right here. That distance is 1. In fact, it doesn't matter where I put that line. It's always going to be a distance of 1. So the hypotenuse is 1. So we have 1/2 over 1. So the sine of 30 is equal to 1/2. And if you have a calculator out, or if you have a calculator, go ahead and pull it out and type in sine of 30. And look, it says sine of 30 is equal to 1/2. So we now know what the sine of 30 is without using a calculator. That's the idea behind the unit circle. And I know it doesn't sound all that great, but it's kind of cool. Let's try the cosine. So let's try the cosine of 30 degrees. Cosine of 30 is going to be the adjacent side. So this is square root of 3 over 2 divided by the hypotenuse, which is 1 again. Okay, what's square root of 3 over 2 divided by 1? Well, it's just square root of 3 over 2. So what is the cosine of 30 degrees? It's square root of 3 over 2, which is like 0.866. So if you type cosine 30 into your calculator, you get 0.866. So now we know what the cosine of 30 is without using a calculator. And it doesn't matter how big our triangle is. Like if I was dealing with a triangle that's much bigger than this, let's say I multiply all the sides by 5. So that would keep it at a 30-degree angle. If I multiply one side by 5 and one side by 6, this is no longer going to be a 30-degree angle. But if I multiply everything by 5, it will stay a similar triangle. It's just much bigger, right? Now, if I still try to find the cosine, I would still have square root of 3 over 2, but this time times 5. And on the bottom, I'd have 1 times 5. And what happens? 5's cancel out. It doesn't matter. And I'm still left with square root of 3 over 2. So even if I'm dealing with bigger triangles, my cosine and sine values are going to stay the same. So what's so neat about this is if you've got the unit circle memorized, you now know the sine and cosine values of all of these 16 points around the circle. So each of these points you've got an x value, which we marked in blue. So I'm going to put x is blue, and a y value to get to that point, right? So I'm going to put that in red. So what those mean are your x value is your cosine value, and your y value is the sine value. So let's take one of these other points here. Let's do the 60-degree angle one. So I'm going to erase this stuff right here. Let's take a look at the 60-degree angle. I know, and you can just type it in your calculator if you want, the cosine of 60 degrees is going to be 1/2. And the sine of 60 degrees is going to be square root of 3 over 2. Why? Because the adjacent side to get to of this 60-degree angle is 1/2, and the opposite side, or the vertical side, is square root of 3 over 2. So when I do opposite over hypotenuse for sine, square root of 3 over 2 divided by 1 is square root of 3 over 2. And that's my sine value, and that's my cosine value. And it works all the way around the circle. So even over here, let's do this one right here. The cosine value, in this case, of 135 degrees. Yeah, it's still using a 45-degree triangle, but this is a 45 degrees technically, but this angle right here is 135 degrees. We call this one a reference triangle. But the cosine value of 135 is going to be the negative square root of 2 over 2, and the sine value is going to be positive square root of 2 over 2. So let's try a practice one right here. Let's say I want you to find the sine value of 240 degrees. Okay, give you just a second to find the sine value of 240 degrees. And you can pause the video if you need to. Okay, so sine of 240. So what we're looking for is 240 degrees. That is, right there. There's 240 degrees. Is this guy right here. The sine value is the y value. So sine of 240 is negative square root of 3 over 2. Okay, let's try one more. Let's do the cosine of 180 degrees. Okay, take a second to find that. If you need to pause the video, you can. Okay, cosine value is the x value. So we want to find 180. There's 180 right there. Cosine is the x value. Cosine of 180 is a negative 1, is value of negative 1. There's your cosine of 180. Okay, sine and cosine, pretty straightforward, pretty easy. You just have to remember that cosine comes first, sine comes second. I like to think of it as alphabetical order, however you want to do it. Now, tangent is just a little tiny bit trickier. Okay, so let me clean up some space here so we have some room to write. Tangent takes a little bit more work. And basically, there's going to be one of 4 different options for tangent. Let's get rid of those. So tangent is opposite over adjacent. So let me get, I'm going to do 45 degrees right here. Oops, I didn't want to do that in blue. Sorry. I'll do that in black. 45 degrees. Okay, cosine, or the x value, it's right there. It's square root of 2 over 2. And the vertical distance also square root of 2 over 2. Okay. So tangent, so here's 45 degrees, is opposite over adjacent. So in this case, it's going to be square root of 2 divided by 2 over the adjacent side, which is square root of 2 over 2. I'm sorry, that was not very good notation for me. I should have said is equal to the tangent of 45 degrees. Okay. Well, what is something divided by itself? It's just equal to 1. So the tangent of 45 degrees is equal to 1. Okay. And the important thing I want you to remember is that tangent, yeah, it's opposite over adjacent, but because we're kind of just substituting opposite side for sine, right? Y is always going to be our opposite side from our angle. Always, always, always. Opposite's going to be our y value. And adjacent's always going to be our blue one, how we draw our line. So even down on this one, here's my triangle right here. Always use the x-axis. Always come up to the x-axis like that. That's where our reference angle would be. So your adjacent's going to be your x, and your horizontal, so your opposite is going to be your y. Okay. So we could also say that tangent is actually equal to, tangent of our angle is equal to sine divided by cosine. Sine divided by cosine, that is always going to equal your tangent value. So on this one, I took my sine value, which was square root of 2 over 2, and I divided it by square root of 2 over 2, which gets me 1. Now you'll see there's other places on here. That's why I said tangent is kind of the trickier one because you have to kind of think about it. There are other places on the unit circle where the tangent is going to be equal to 1. That's where my sine, my y value divided by my x value is equal to 1. So these numbers have to be the same number. So at 60 degrees, it's not going to work. It's going to be something else. 135 is close. Square root of 2 over 2 divided by negative square root of 2 over 2. The tangent here is going to be negative 1. Okay, so at the 45 degree angle ones, those are going to be 1 or negative 1. So here at 135, it's negative 1 because one of them is positive, one of them is negative. Down here at 225 degrees, they are both negative. So sine divided by cosine is going to be positive 1. So the tangent of 45 is 1, and so is the tangent of 225, also equal to 1. And tangent at 315 is going to be equal to negative 1. So the 45 degree ones are pretty easy. Okay. Let's look at a little bit harder ones. I'm going to start with the easier of the two. Let's look at 60 degrees. Okay. So this one is going to be when the square root of 3 over 2 is my y value and 1/2 is my x value. Notice that's different than down here in 30. They're swapped around. If I have square root of 3 over 2 and I divide it by 1/2, okay, I want to simplify that. When you divide by a fraction, it's the same thing as taking your numerator, square root of 3 over 2, and multiplying by the reciprocal of your denominator. So instead of 1 over 2, I'll have 2 over 1. This one works out really nice because the 2's just cancel out and I'm left with the square root of 3. So if the square root of 3 over 2 is your y value and 1/2 is your x value, your answer is going to be, or your tangent value is going to be the square root of 3. So over here, same thing happens. Square root of 3 over 2 is my y, 1/2 is my x. It's negative, so my tangent over here is going to be negative square root of 3. Down here at 240, same thing. My y value is square root of 3 over 2. My x value is 1/2. They're both negative, so when I divide them, it's going to be positive square root of 3. And then over here, negative and positive, it's going to be negative square root of 3. Those are my tangent values at those 4 places. Okay, you'll notice that at 30 degrees and 150 and 210 and 330, they use the same numbers, but they're different. It's 1/2 is the y, square root of 3 over 2 is the x. So let's clean this up just a little bit. Let's see, let's get rid of this stuff over here. All right, so let's look at the 30 degrees and see what answer we get for 30 degrees. Let's get rid of those two. Don't need those. Okay, so what is the tangent of 30 degrees equal to? So we've got the y value, which is 1/2, right? 1/2, divided by the x value, which is square root of 3 over 2. When I do our little flip and multiply trick, I'm just going to keep this all the same color. I hope you don't mind. It's just annoying to switch back and forth. 1/2 times the reciprocal of this, so 2 over the square root of 3. This is nice. Again, the 2's cancel out, and I'm left with 1 over the square root of 3. Now, in math world, for whatever reason, we don't like having radicals in the bottom, so I have to do something called rationalize the denominator. So what I want to do, I don't want a radical in the denominator. So I'm going to do a little trick. I'm going to multiply it by 1. Because what happens when you multiply by 1? Nothing happens, right? Now, I don't want to actually use the number 1 because that would be silly. But I am going to use something that's equal to 1. I'm going to multiply it by the square root of 3 over the square root of 3. Something divided by itself is still equal to 1. So I'm multiplying this number by 1, and it's not going to change its value. It's just going to change the way it looks. So what this gives me is 1 times the square root of 3 is square root of 3. The square root of 3 times the square root of 3 is the square root of 9. Well, what is the square root of 9? It's 3. Square root of 3 over 3. That is the exact same thing as 1 over the square root of 3. They mean the exact same thing. It's just this is the version that we'll call it the most simplified version because it doesn't have a radical in the bottom. Okay, so all of these ones where your 1/2 is in the numerator and your square root of 3 over 2 is in the denominator, it's always going to be, your tangent is always going to be square root of 3 over 3. It just might be negative. So like over here at 150, 1/2's in the numerator, negative square root of 3 over 2 is in the denominator, so it's negative. So it's going to be negative square root of 3 over 3 is going to be your tangent value. Those are two good numbers to memorize, that your tangent can either be square root of 3 over 3 or it could be square root of 3, and know when it's different, what the difference is and when they occur. Okay. Now, tangent still gets a little dicey because there's still 2 other possibilities for tangent. Let's look at, we've looked at the, let's see, we've found that tangent can equal 1 or negative 1 at the 45s, and it's going to equal square root of 3 or square root of 3 over 3 for the 60s and 30s. But what about the 90s? Okay, what happens there? So let's look at this one right here. Tangent of 0. Tangent of 0 is equal to sine 0 over cosine, which is 1. 0 divided by 1 is 0. The tangent of 0 is 0. In fact, same thing with tangent of 180 degrees. It's also going to be 0. But check out 90 degrees. Sine value is 1 and the cosine is 0. You cannot divide by 0. Tangent does not exist at 90 degrees. It is undefined. Okay? So tangent at 90 degrees, if that's what the question was, is undefined or no solution or something like that. Okay? So let's recap we'll just recap the lesson here. So sine values are going to be the y values of your points. Those are going to be the sine values at those angles. Oops. Okay? The x values are your cosine values of those angles. Okay? And your tangent is the sine, the red, divided by the blue. And your possibilities for tangent are, it could be positive 1 or negative 1. Those happen at the 45s. It could be 0 or undefined. Those happen at the 90s. And then everywhere else at the 30s and 60s, it's either going to be square root of 3 or square root of 3 over 3. Those are your 6 possibilities for tangent. I said 4 earlier, but it's actually 6.